Hey everybody, this is Dave Shopius. Up until now, I've just shown off my B9 arm that I've built on my workbench in pieces, kind of half put together and working here and there. I'd like to kind of show it to you now that I've got it mounted on the B9 itself, on the CSS, the Central Support System, or Storage System, whatever you want to call it. It's working pretty good. I've had some trials and mishaps and problems the last couple of weeks with my coding and the mounting and getting everything to work. It's all a learning curve for me. I haven't done a whole lot of coding in Easy Builder, just basic stuff. So, but the hardest thing was getting it to retract into the proper position and on center, so it comes into the torso properly and at the right angles and the speed. So I think I got most of that worked out. I'd like to kind of show it to you now how it all works together and give you a really quick tour. I'm not going to go into a lot of detail, I think. I got a bad habit of doing that. But basically a lot of this has already been covered. I want to show you basically what I have here as far as wiring and mounting. The ARS system, which I call it, is down here. It's a table of sorts that the arm itself slides in and out on. Again, that's all covered in other videos. The tolerance to get in and out is kind of tight. It slides up into the arm, as you can see, so I can get it fully retracted and fully extended. And again, it has to be very well centered to go into both that spot and the hole in the torso that I don't have on right now, obviously. That'll be the next step, is getting all this taken off the CSS after I have it working now and getting it installed inside the CSS. So that's going to be like a little Houdini act. I'm fairly certain that it'll work. All my calculations and measurements show that it will. I've never had it installed inside. I've got a process in my mind how to do it. The only thing I'm a little bit concerned about is down in this area here where the torso curves down around this motor. Again, my measurements say it'll work, but that's left to be seen. That's one of life's little mysteries at this point. So, pardon my voice. We're moving into fall right now, and I've got a fall cold, of course. But anyway, you can see what I've done here. I needed to run all my control cables and power cables into the torso, into the CSS itself, where all the control is. And what I did is, again, this is on other videos, but you can see I've got an arm built that slides in and out, pardon the glare, and it kind of keeps all the control cables in alignment and lets them flex properly. And as the arm goes in and out of the torso, it keeps them all in position. What I've done is I've used, for the connections, easy connect and disconnect, I've used Molex pins and Anderson power pins here. These plug in and out very quickly, very nicely, and they're easy to install, and they carry pretty much the full load according to amps. Molex will only take up to 10 amps. These things you can buy them according to amperage. These are rated at 30 amps right here. So the power and control cables go up through here. They actually disappear into the CSS in different locations. The power goes up, rather the control goes up and power comes down, control goes down. This is all, pardon the shadows, control is all done by Easy Robotics Easy B. I've got one for the main robot up here, and just about a few inches away I've got this one here is going to be handling all the arms, both arms. Right now it's only handling one. The control and position is handled by two saber tooths, which are mounted right down in here. One for the elbow and one for the ARS, which is the arm retraction system, as I like to call it. It's all being powered by I think this is an 80 amp power plant down here, a mean well power plant. There's a good shot of some of the pins, Anderson power pins that I've got for easy disconnection. If I ever want to take this, when I want to take it all apart and pull the power plant out. Just a little note on the power system that I'm using. I've overdone it. I know I have. I have got probably enough power supplies on here to power my whole house. This is an 80 amp power plant. I've got another 12 amp up here to handle everything up in the bubble. These, I got twin power units down here. They're all they're each one of these is 12 amp, 12 amp, 12 amp. For like the torso lights and everything else that I have going on in this thing. And then I have another one down below here. You can't see it probably. That's another 12 amp handling everything in the legs. This could cause problems if you don't do it right. You could have ground loops, heat problems, all that. But these are switching power supplies, so very little heat. It controls everything properly inside of itself, and they're very efficient, is what I was trying to come up with. So anyway. Again, I probably have almost 130 amps of capacity on this robot here to handle everything. Again, I overdid it, but hey, we're in the land of plenty, so why not? So what I'd like to do now is power it on and show you how it, hopefully, when I power this on, you'll hear the Easy Bees come on and connect to my network. It's all Wi-Fi controlled through my laptop over here. It's my little cheap laptop. Warning up front, I probably have some bugs to work out. You're probably going to have to see some mishaps and some glitches. If it does happen, we're going to stop and straighten it out. Again, I'm no expert in coding, so a lot of this is pretty rough right now, and I still have to do a lot of refining on my scripts and get things to run more smoother. But anyway, let's just turn them on. I got up right here.
I have successfully connected to your network.
That's a good sign. I have 3 Easy Bees right now controlling the 2 up on top, and then another one down in the blade section that I told you about, and they're all they all just hooked up to my Wi-Fi network on my house. The main Easy Bee handling most of the motor functions. Most of the functions throughout the robot, other than the arms. I do not have a speaker in that, so you didn't hear that come on. That's hooked up to my main sound system. But again, that's all recorded on a different video. You can look that up and check all that out. I'm going to start up Easy Builder now, which will hook up to all the Easy Bees, and he'll run through a homing routine where he twists and turns and bends over. And what that is, that's homing all the encoders on this robot, so he'll run properly. So let's start up an Easy Robot here. Let's see here. Easy Builder starting up, and you'll see a little warning screen that's just telling me that I need to hook up my microphone for my voice recognition, which I do not have right now. I'll click on that, and the Easy Builder will come up, and he'll start homing properly, hopefully. 3 connections. You see them all 3 connected right there. Let's pull back and watch him do his thing here. The ARS is homing. The waist is homing, the leg section is homing, the rest is just for show. You saw the bubble lifter going up and down, the claw opening and closing. Again, that's all just for show to make it look like he's doing something when he's booting up. With the torso on and the sound system connected, he will be talking to us as he's booting up. I'm going to turn off the personality generator now, so he doesn't start doing weird things for me. And I'm going to turn off some other stuff here so he stops moving around. Okay, now he's homed up, he's centered. What I'm going to do now is turn on a script that will pull the arm out and move him up to a point where we can start showing off, which I like to do. So hopefully, keep your fingers crossed, this will work. Let me get to the side so we can really, well, let me get to this side. Okay, he's going out and he's going to go up, hopefully. There we go. Now, if everything was together and I was had him just in regular operation mode, he could be posing right now. Maybe open the claws, tip the wrist down so he's attacking, pointing down, pointing up. But you can see the ARS is right now. He's already out to the end of the ARS there, the slide, pointing up. Kind of a cool thing. So let me start up another script here, and I think what we're going to do is we're going to start up the arm servos so his wrist will snake around. Let me get to the side just a touch here so you can kind of see what's going on. Okay, now that's cool. Let's start up the claws. Hopefully, I'm having problems with the claws. I got to redesign these things. They're sticking sometimes, so hopefully they'll open and close for us. Oh, there they go. Good. Okay, the claws are working. They're opening and closing nicely. I got a loop kind of coded for that. And now everything's working except for that elbow joint. And let's get the elbow working. So I got a separate script for each one of these, and I'm going to refine a lot of these so they'll all be smooth and interact with each other. But right now this is just for showing off. So he's going up and down. And there you go. My Lost in Space pinball machine in the background there. So he's got a pretty good range of movement here. This is not even it. This is just the limits that I've got programmed in right now. So there you go. Now, first time I've shown this off with him on, with his arms attached. Okay, let's shut her down. I'm going to have to do this one system at a time. Later I'll have them all working together. I'm going to hopefully shut off the claws first. Hopefully this will all work. I haven't done it yet, so. Okay, claws are off. They're together. Now I gotta shut off the elbow. I'm gonna actually shut off the wrists, because everything's gotta line up. Okay, wrists are shut down. Now I'm gonna shut down the up, down. Okay, now here's the Fiesta Resistance. I think that's how you say it. in honor of our French friends. The hardest part I had to come up with was, like I said, coming up with a script that will read the feedback off the encoder. Actually, it's not an encoder. It's a potentiometer back in here that reads the position of the, it's a flat potentiometer. It's, again, you can look at it in one of my videos. That reads the position of the elbow. We want to get that thing exactly straight, and there's some latency in that potentiometer, so whether it's coming from the top or the bottom, I had to do a little bit of mathematician work. I know that's not a work, but it's I had to do some math. So it comes down exactly in the center, either coming from the top or coming from the bottom, and then not retract in on the ARS until it knows that that is in center, or else disaster can happen. You can imagine if the torso is in place and that arm ARS tries to retract into the torso with it in the up position or the down position or any other position rather than dead center. So keep your fingers crossed. Hopefully it'll come down dead center. And my coding is correct. So it is not. Oh, okay, well, let's try that again. Again, I said there'd be some problems here. Okay, let's see what happens now. Okay, there she is. Dead center. Nice. Okay, and you can see that she came right into position. You can see what kind of tolerance I have there. And it's all the way to the back. So there you have it. Like I said, I got a little bit of problem here and there to work out in my scripting. But it works. Yay! My next thing is I got to take it all apart, get it into the, get the torso and everything on, mounted, and get this unit into the torso somehow through that little 7-inch hole we have in the front and the vents. I have confidence I can do it, so keep your fingers crossed and keep good thoughts in your head for me. I'll come back with another video when it's all in place. Thank you. Bye-bye.